Welcome to our electrical principles class. We are going to look at electrical quantities. And hi, the presenter is Michael Mwemangesa. And would like first of all to understand. Just a minute. Just a minute. My machine is misbehaving. Kindly wait. Okay, just a minute. My machine is misbehaving, eh? Okay, I think now you can see. Are you able to see my screen? Ekile ngoko ni ite. Ekile ngoko ni ai. Are you able to see my screen? Hello? Are you able to see my screen? Okay, thank you. Now let's proceed. So as I had said, we are going to look at electrical quantities. And to begin with, we are going to look at the learning objectives or objectives of this lesson. The first objective that we are supposed to achieve at the end of this lesson is to define the terms basic and derived SI units. Then the second objective is to state the basic quantities and their SI units. That is, you're supposed to state the quantity itself, then we give its SI units. The third objective is to explain the derived quantities and their SI units. In this one, we will be required to explain a bit what we understand by derived quantities, and then we give their SI units. Then our last objective is that we shall involve ourselves in some few calculations regarding basic and derived quantities. Now, let's first of all now define the terms. What do we understand by the term basic SI units? The basic SI units are measurements of a base quantity, or these are units adopted for measurement of a base quantity. Examples of base quantities are mass, resistance, and so many others that we shall look at just in another slide below here. When you come to derived quantities or derived SI units, we say that these are units formed through combination of the basic units. That is to say, the derived units are quantities that are derived from the basic units. An example is the velocity, and another example is force. That is to say, if we have we need to know the unit of velocity, we shall find that it has both the meter and the second. So now that it has combined two basic units, that is length and time, to give us m and s, now it qualifies to be a derived unit. Are we together? Are we together, learners? Okay, let's go to the basic quantities and their SI units. There are 7 basic electrical quantities, and we need to learn these ones through a table. So I'm going to display the table for everyone to visualize and see. Now, this is a table that is showing us basic quantities and their unit. We have said there are 7. So the first one is length. Length is measured in meters, abbreviated as capital M. Mass is the second quantity, which is measured in kilograms. Then it is abbreviated capital K and a small g, kg. Then the third unit is time, which is measured in seconds, abbreviated as capital S. We have the electric current, measured in amperes, abbreviated capital A. Thermodynamic temperature, measured in Kelvin, abbreviated as capital K. We have the luminosity density, measured in candela, abbreviated as capital D and a small d. And our last basic quantity is the amount of substance, that is a mole. It is actually measured in mole, abbreviated as mole, MOL. And that one has brought us to the end of basic quantities. Let's now embark on the second quantity, that is the derived quantities and their SI units. As we said earlier, that the derived quantities are those quantities that are derived from other quantities or from basic quantities. Now we need to begin with our first derived quantity that we are going to look at, which is the charge. Charge can be defined as the quantity of electricity flowing per unit time, and it is measured in units called coulombs, abbreviated as capital C. Now, what do we mean by this term, a coulomb? Coulomb is defined as the quantity of electricity which flows past a given point in an electric circuit when a current of 1 ampere is maintained for 1 second. Thus, we can say that coulomb Q is equals to the current times time. and then from there we get a formula that is used to calculate charge or quantity of electricity, which is given by Q is equals to IT. So from that we have come up with a formula, a mathematical formula that can be used to calculate charge. Later on we shall use this formula to go through an example when we start embarking on the calculations. Let's look at our second derived quantity, which is force. And the force can be defined as a push or a pull on an object with the mass that causes it to change its velocity. And we say that the SI unit of force is the newtons. Force is measured using a newton, abbreviated as capital N. Abbreviated as capital N. Therefore, we have a formula that is used to calculate force. So force is given by MA, whereby M here represents the mass and A represents the acceleration. So in that case, we are having two basic quantities that can give us the unit of this force being kilograms per meter per square second, and what we refer to as kilogram per meter per square second is what is referred to as a newton. So 1 newton is equivalent to 1 kilogram per meter per square second. We shall look at that later during our calculations. Let's go to the third derived quantity, which is work. So when a force applied to move an object with a mass over a unit distance is called work. So that force is the amount of force that is required to move an object over a certain distance d. Over a certain distance d is referred to as work. So in that case, the unit for measuring work is the joules. So unit is measured in joules. Now we proceed to our last derived quantity that we are going to look at, which is power. Power can be defined as the work done per unit time. So in short, what we mean by power, we can simply define it as the rate of doing work. The rate of doing work is what is referred to as power. So in that case, we have a mathematical expression that governs power. That is to say, P is equals to W out of T, where W here represents work and T represents time taken to do that work. Therefore, work can be given by PT, since we say that work is the same as the energy. Now that brings us to the end of these quantities, and there is a small video here. There is a small video here that demonstrates all what we have said about derived quantities. So later on, I'm going to leave this video with you. You will watch it later. You will see how we come up with the derived quantities and how they are obtained using mathematical formulas. Now let's embark on our last objective, that is calculations involving electrical quantities. Our first example is this one. Can you write it down? Just write it down. If a current of 5 amps, if a current of 5 amps flows for 2 minutes, flows for 2 minutes, find the quantity of electricity transferred. Find the quantity of electricity transferred. So in this case, quantity of electricity Q, we said that it's given by IT, that is current times time. From our question, you've been given current as 5 amps and the time given is 2 minutes. So we have to convert this time to SI units of time, which is seconds. So 2 minutes is equivalent to, since 1 minute is equivalent to 60 seconds, then we take our 2 minutes and multiply by 60 to get 120 seconds. And therefore, if we substitute our values in the equation governing quantity of electricity Q, then we shall have 5 times 120, which will give us 600 coulombs. 600 coulombs is the quantity of electricity that will now be transferred. Since our time is almost over, guys, let me just give you an assignment that you are going to go through, and we shall look at it during our next class. So let me give you some 2 minutes to write down the assignment. Just 2 minutes. Kindly write down the assignment as it is displayed on the notice. Yes, Okay, I think now you have written down. Thank you for attending the class. This has brought us to the end of our lesson. Enjoy your evening. Any question? I think there are no questions, guys. Enjoy your evening. Enjoy your evening.